Okay, 4.5 triangle congruence by ASA and AAS. We have learned the first two. Here's the second two that we're going to learn. So angle side angle is ASA postulate, and it says if that it's going to be two angles. So let me say two angles, and the connecting side of one triangle are congruent to two angles, and the connecting side of another triangle, then the two triangles are congruent. So what they mean by connecting side is the side in between those two angles. So let's take a look over here. We could see here I have two angles and a side in between, and here I have two angles that are also congruent with a side in between. That means that these two triangles are congruent. That's all that theory means. So if we have two angles and a side in the middle, two angles, side in the middle, they're all congruent with each other, then we know the whole triangles are congruent. Cool. Let's go to the next one. Okay, angle, angle, side. So very similar, but now it's a different order. This says if two angles and a unincluded is the word we're looking for. And an unincluded side. This word kind of means not in between is a way to think about that word, unincluded. Unincluded side of one triangle are congruent to two angles, and the corresponding unincluded side of another triangle, then the triangles are, well, they're congruent. So let's take a look at what that means on the picture here. I have two angles and two angles, and look, the side congruent is the same side congruent over here. So it goes angle, angle, side, angle, angle, side. So we have two things that are congruent. These two triangles have to be congruent. Now, what if that thing wasn't marked and instead I had that one marked? Okay, so pretend like that's not there, and I have that one marked. Well, this would still be angle, angle, side, but this would be a different angle, right? Because this angle, which is the first one that we would mention to go angle, angle, side, does not correspond to this angle. So these two triangles would not necessarily be congruent because they don't go in the exact same order. They need to go in the same order. Now this triangle could be rotated or flipped or whatever, but it still has to go in the same order. So this situation would be not congruent. Okay, let's take a look at some examples here. And we want to figure out by what postulate or theorem we know that the triangles are congruent to each other. So let's take a look at this first one. Well, I'll do this one with you. Looks like we have a side. We have a side, so I'm going to just write that, and I'm going to try and color code this. So S and S, I got that. And it looks like I have a 90-degree angle and a 90-degree angle, so that is an angle. So I'm going to write angle right here, angle right here. And then the other thing that's not given, but we can kind of see, is that these two angles are vertical, and that's whenever you have like an X. And these two angles are vertical, making these two angles congruent. So let's mark those as angles as well. And we can see, starting from the blue, we got angle, side, angle, angle, side, angle. So this would be congruent by ASA. Alright, I want you guys to try these next two. Just take a look at them, see if you could figure them out. I'll put the answers up there in just a little bit. You may want to pause the video, because I'll put the answers up in just a second. Okay, so let's zoom in on this first one. Well, again, it looks like I have an angle and an angle. And then up here, I probably should use the same colors, right? Another angle, another angle. But that's only two angles. Do I have anything else? Well, I do, because look, this side here, RS, has to be congruent to itself on this side of the triangle and on this side of the triangle. So RS is congruent to itself. So I'm going to mark that like this. And that's a side, and that's a side. And now if you look at it, I have angle, angle, side, angle, angle, side, making these two triangles congruent by angle, angle, side. Let's go to the next one. Now this one, we're going to find out there's actually two ways we could do this. So let's start at the top. We definitely have an angle here, and we have the same angle here. Color code it. We have a side here, and we have a side here. And then we have an angle down here, and the same angle up here. So we could go angle, side, angle, angle, side, angle. Okay, so ASA is one of the solutions. But check this out. if we were to use purple, we could say that these two angles are congruent as well because they are vertical. So we could add another angle in here, meaning we could either go angle, angle, side, angle, angle, side, or angle, angle, side, angle, angle, side. So if you said AAS for this one, that was also a possible answer. There was two ways we prove that one congruent. Okay, so we've gone over angle, angle, side, and angle, side, angle. There's one more that I want you guys to see, and that is the hypotenuse leg theorem. But in order to do that, we need to talk about some terms. Really important for you to know, in a right triangle, the longest side of a right triangle, this longest side, the part that's always opposite the right angle, is the hypotenuse. So I'm not going to spell it out because it's spelled out right there. But the hypotenuse is the longest side of the triangle, and then the other two sides are just called the legs. Notice here, this is a leg and this is a leg. So the legs are always touching the right angle, and the hypotenuse is never touching the right angle. It's always opposite the right angle. So let's see what the hypotenuse leg theorem says. Well, it says if the hypotenuse, let's see if I can fit it in there, and a leg of one right triangle are congruent to the hypotenuse, and a leg of another triangle, then the triangles are congruent. So there's also the HL theorem. So if we ever get a hypotenuse and a leg of a right triangle, and we know the hypotenuse and the leg are congruent, then right away we can go to assuming that those two things are congruent, and all we need is a hypotenuse and legs to be congruent and a right angle. So let me give you an example. Probably zoom in, and hopefully my drawing won't be too horrible. But let's say I have this triangle, and then I have another triangle kind of stacked like this. And they tell me, hey, this leg is congruent with this leg, and this hypotenuse is congruent with this hypotenuse. And they tell us that these are both right triangles. Well, that is enough to determine that these two triangles are congruent. Just like that. Alright, the summary here. So we've now learned the 5 primary ways to prove triangles congruent. We have SSS, SAS, ASA, AAS, and HL. Why is there no AAA or SSA? I want you to try and think about that. That's a really good question. And if you can explain that well, then you've really mastered this topic. So I'm going to leave it at that, and see you guys later.